Hello students, Ms. Slyman here with a redo of a set of notes for example 6. So it turns out I had made a mistake when I made this first video, so this is the second one. If it's the first time you're watching, then perfect, because I'm going to get it right this time. So starting away, first off, we've got an inequality, so I'm going to be thinking about number line and sign diagrams and whether values of x make this true or false. Straight away, I see that x cannot be negative 2/3, so I know that's going to be a value on my number line. Let's put in a 0 and a 1, so then negative 2/3 is going to be around here. And I can fill that in right away with an open circle because I know I cannot be negative 2/3. The other thing I want to look for to add to this line is any place that these are equal. Now, I don't want equal, so that would also be an open circle, but I want to know, is this line x over 5, because that's just a line, ever going to be equal to whatever shape this rational makes? So let's try and solve that equation. I'm going to cross multiply, and again I'm going to make it an equation. So 3x plus 2 times x equals 10x squared minus 30x plus 40. Expanding, that's going to be 3x squared plus 2x. Move it to the other side. 7x squared minus 32x plus 40 equals 0. And now let's see if we can solve this. So I'm going to look at the discriminant, and that's going to be 32 squared minus 4 times a times c. Put that into my calculator. Do a quick little test here. Hopefully my calculator will open quickly. All right, so we had 32 squared minus 4 times a times c. And that gives us a negative number. So this left-hand side is never equal to this right-hand side, so I don't have anything else to add to my number line. The only thing I care about is this negative 2/3. So now trying to solve this and determine where it's true, I could have either everything to the left, everything to the right, neither one, or both. And so I want to test for my solutions. I should have made this -1, not 1. So let's test both 0 and -1. Of course, 0 is the easiest one to test. If I test 0, I'm going to get 0 is greater than 8 over 2. That's false. So that side's not true. Plugging in -1, let's test that. -1/5 is greater than 2 plus 6 plus 8. So that's going to be 16 over -1. -1/5 is greater than -16. That's true. So that means that every value here to the left should be true. And if I want to verify this, we haven't looked at the graphs yet. That's what's coming next. But I could take a peek on my calculator to have an idea. So I'm going to go ahead and graph this system. So that first equation is x over 5. The second equation I'm going to put in fraction form. And we had 2x squared minus 6x plus 8. And then coming down into my denominator, 3x plus 2. So now if I look at this graph, I'm going to zoom and just have a standard window. So that's number 6. All right, there's my line. That's the x over 5. And this red one must be my rational graph. Here's my negative 2/3 here. There's that line there. And I can see that to the left of negative 2/3, the line is always greater than the red graph. But from the right, the red graph is above the blue graph. And here it looks like they might be equal, but let's zoom in around that. So I'm going to zoom in from 1 to 3 and 0 to 1. So I'm going to change my window. My x's I'm going to take from 1, oops, just 1, 1 to 3, and my y values I'm going to take from 0 to 1, just to look really closely at what's going on there. My line again. And there's my curve. And sure enough, I can see that they never meet, which is what we got here from this discriminant. So looking at this, everything for x less than -2/3 makes this inequality true.